Alright, time for another draftphysics.com, debatephysics.com, also video presentation. Well, here there's also draft science on YouTube, but, hate to be dependent on YouTube, evil corporation and all of that. So, anyway, alright, so the original video by Steve Mould that claims the law of the lever is actually junk science, and the real truth and conservation of momentum, junk science. And the real truth is that one of the simplest tools discovered, let's say by humans, the lever, actually conserves kinetic energy. It doesn't conserve momentum. And it validates completely and entirely the Leibnizian notion that 4 pounds dropped 1 foot is the same energy as 1 pound dropped 4 feet, which is 1 pound going to velocity. So basically, since you can do it one way, you should be able to do it the other way. So they're making this assertion. Okay, I'll draw the assertion. Yeah, let's do that. Let's just say, just show how simple it is and how what it says about how levers function would make levers absolutely useless as tools, because they would lose so much energy, so much momentum, so much capacity to do work would be destroyed. So the simple example experiment is you put a certain amount of force in. So in this case, we'll just say it's a 2 mass, okay, going 1 velocity. And you have expectations about what you can get out. That is, if I put this in at 1 distance, I can go 2 distances with a half mass. Okay, so a 1 mass. And the expectation, the logical expectation would be that, okay, the law of the lever basically says multiply the distance times the mass, and those two things, those two quantities, if you make them equal, you will balance the lever. Okay, and so it's as simple as just this, making a device that oscillates, and I've done it and it works fine, obeying the law of the lever. But they say that's a trick. I'm being fooled by the balance, the scale. The gravity scale is lying to you, okay, because it doesn't have it right. And so what they say will happen is that this won't be able to go the logical 2 velocity, 2 times 1, same as 1 times 2 kind of argument. No, it'll go 1.4. That's as fast as I can make it go. So the 1 mass can only go 1.4 the velocity, and it has to lose 30% of the momentum. And the Leibnizian example is just taking this, 1 step farther, in the sense that you're just saying it's going to be 4 units of distance that you're going to put the 1 mass, and that you're going to have a 4 mass over here. And obviously this is all, it should be completely reversible. That is, what the lever does one way, just like pulleys, it should do the other way. So you can use them in either direction. So that their simple argument is that I can have a 1 mass, okay, and the logic says, okay, I need 4 times the velocity. 4 mass 1v, I'm going to need a 1 mass 4v. But no, they say that the 1 mass merely going, so a 1 mass going merely 2 velocity will somehow equal a 4 mass going 1 velocity. Obviously this only has 1/2 the momentum, okay. So they're basically saying the levers make free momentum. Now, it seems that they're perfectly comfortable with the idea of making free momentum, that is, converting the momentum of something like a wrecking ball, and the idea that you could just bang it into another wrecking ball, a bigger one, and create even more momentum to hit the building with. That anytime you collide a light thing into a heavy thing, you can increase the amount of momentum in the universe moving in a direction. Scientists are apparently perfectly comfortable with that idea, which is absolutely ludicrous. So obviously this is nonsense. I mean, it's idiotic. Okay, it can't happen. Okay, you can't use the 1 mass going 2 velocity and lift, okay, at 1 velocity the 4 mass. Never going to happen. It's not possible. It's just stupid and wrong. Okay, and so Steve Mould's video has 1 million views now, making that argument, claiming that it's true. So in spite of the 2,000-year history of basically believing levers conserve momentum, the law of the lever is basically just saying it overtly. Okay, the distance is exactly the same as the velocity. I mean, you know, people use the word proportional to. Well, you could just say, no, it's exactly the same. 2 units of distance, 2 units of velocity. 3 units of distance, 3 units of velocity. 4 units of distance, 4 units of velocity. So it's basically just yelling at you, mv has to equal mv. It's not saying kinetic energy anywhere. There's no mv squared, okay, for 2,000 years. And now because somebody puts them on the spot and asks them to rationalize their theories, they sit there and contrive this nonsense. And so they just state it. They don't show you any experiment where it actually works or it happens. And again, in spite of the evidence against, which is as obvious as this, okay, it's as obvious as just creating, with a fulcrum on top, creating a balance, okay, putting a 1 mass, 4 units of distance, and then a 4 mass, okay, 1 unit of distance, and that object balances perfectly with this going 4 velocity and this going 1 velocity. And it works perfect. It's just showing you that whatever the energy is, which is the mass flipping from one side to the other, a little bit of the mass of the object flips from one side to the other, that's what's causing the oscillation. And it's as much work to move the 1 mass at 4 velocity as it is to move the 4 mass at 1 velocity. It's proving it, that it happens, it works. And all you're saying is if I put a little extra energy in, I could lift the 1 mass. I could throw it, or I could throw the 4 mass if I allowed them to release from this device, and they would leave with these velocities. And it's a demonstration of what equals what. Clearly a 1 mass going 4v is the same capacity to move stuff in the universe, energy, weight, pressure, as a 4 mass moving 1v. It's clear. And yet they're denying this and saying this is lying to you. The gravity balance is a lie, and that the true equality is a 1 mass going 2 velocity, which won't balance, which will swing decidedly in this direction, okay, and stay down there, because the 4 mass going 1 velocity, the 4 mass period, okay, is no chance that you're going to be able to balance it with merely a 1 mass going 2 velocity. It won't work. It won't happen. It's not the same pressure, not the same momentum. It doesn't take the same energy to move one as it takes to move the other. And here I have to make these videos. So in 3 weeks, since Steve Mould made his idiotic and moronic video, there hasn't been a single rational response. Now there was one response by one physics teacher, which is scary, who didn't watch the whole video, and he thinks Steve Mould is defending the original theory of the law of the lever. He doesn't realize that he's debunking the law of the lever and claiming kinetic energy is what moves levers. Now, Minute Physics put in his clip that basically proved pulleys do conserve momentum, which again doesn't make any sense, that nobody out of those million viewers, not one of the million viewers, was, rationally conscious enough to recognize that it doesn't make any sense to show a clip proving that pulleys conserve momentum and then arguing that momentum doesn't have to be conserved. Doesn't make any sense at all. And not one, not one person a person capable of making a video could make a video saying, gee, this is really junky science. It's real garbage. I mean, trash. I mean, silly. It might as well be presented by a flat earther. It's so bad. The science, the physics is so bad, it might as well be presented by a flat earther or some other kind of religious kook. Because it's Sasquatchian science, it's UFO science, it's bullshit is what it is. And it just, so I'm just, just pointing it out. I mean, 1 million views, and not a single person recognizing, hey, that's really garbage he just said. So all the people that watch, we know Action Lab watched the video, we know lots of people watched that video, and not a single one of them said, Hey, Steve, you're talking shit, man. You can't talk shit on the internet. It's bullshit. You gotta quit doing that. You're talking to kids, fucker. You can't be telling them this nonsense. And make a counter argument. Not one. Just saying. So that's the circumstance we're in. It's that the physics is that bad. Okay, so I'll just do this in pieces. So I'll probably do another Paul Nord. Just won't let it go. Okay, so he keeps trying to say something to recover his reputation, but it's going to be impossible because he still hasn't paid enough attention to realize he's making false accusations against Steve Mould. He's accusing Steve Mould of defending the law of the lever, defending the conservation of momentum, when clearly Steve did exactly the opposite in the video. He's defending the 1.4 idiocy. He's defending the idiocy that a half amount of momentum at a higher speed, okay, a bigger V, okay, and a smaller M, and half the momentum can create something with twice the momentum. That's what he's defending, okay, which is Paul's dopey notion. Okay, but Paul's really dopey, so there's really no point. But anyway, I mean, he's wrong about so much, and all these people again, they should all be saying, "Well, if you're going to tell me what the truth is, why don't you show me the truth?" Okay, in all these other videos, he takes all this time to bounce balls inside of bottles, under tables. I mean, a million experiments, bouncing things off of different things, buying all kinds of resource, doing all kinds of experiments, and the simplest experiment you could get, lever, you didn't bother. Let's not bother doing the experiment. Hell with that. Just amazing bullshit. And nobody calls bullshit. I am the only person calling bullshit. That's it. One person. Out of million, one. Bizarre. Strange. Incomprehensible, frankly, to me, that you could all be so dupey. Okay, that you just sit there and watch something and say, oh yeah, it's fine. He doesn't prove anything. He just tells us what the truth is. And that's all we want from our science. Just tell me the truth. I don't want to be bothered thinking about it. This is idiocracy. Congratulations, science. You're now part of Trumpian idiocracy. Bravo. All right, I guess we'll do some Paul Nord email and such. And so I can read this first part, and then I think I can put the rest on the screen. We'll see without doxing myself or something. So it says, something always goes wrong. No, it should be okay now. So he says, thanks. Oh, Jesus. Thanks, Gary. You refuse to accept any proof or mathematics I can provide. So he doesn't provide any evidence in any kind of reasonable form, like experimental evidence. And obviously mathematical proofs are worth nothing, as I do point out. I won't take your bet because you won't accept any of my results. So again, I asked him specifically what results have him convinced. I mean, how does he gain his confidence in this MV squared stuff? What experiment made it so clear that it must be true? I mean, he wouldn't answer that question. I guess you are free to decide that I am just another part of the vast conspiracy. They always call it a conspiracy, so being stupid is a conspiracy. So the ignorance in the world is a conspiracy. Religion is a conspiracy. No, it's not. It's just a symptom of the fact that human beings are irresponsible owners of neural capacity. They can't, apparently, grow any integrity bones. Yeah, none. Hell-bent on describing mechanical systems using Newton's laws, so he's pretending he's a Newtonian when he's defending Leibnizian physics. Again, the irony is just so thick. All right. It hardly raises to a level of a religion. So obviously it is in every way a religion, in the sense it's just dogmatic proclamations by pious asswipes. Okay. But you do you. Whatever that means. Thanks again. So I think he says, but you do, apparently. But he added another you for some reason. Thanks again for linking to my video. I've gotten a lot of hits with this little debate. Yeah, that's all that matters, right? Oh, yeah, 60-second science. Great idea. Yeah, no, it's a really bad idea. Your thought experiment about the spinning rod is a good insight on this problem. And again, it's useless without evidence. Illustrates how Steve applied the work-energy theorem incorrectly. So he still, at this late date, 3 weeks later, he still hasn't watched the whole video, and he doesn't realize that Steve was arguing for conservation of kinetic energy and the 1.4 thing. Yeah, so he still hasn't figured that out. So he's still slandering, essentially, Steve Mould is doing something wrong when he's in complete agreement with Paul's moronic perception. But it's very ironic. All right. So I'll read my reply. All right. You should be able to read along. Okay. You refuse to accept any proof or mathematics I can provide. Mathematics doesn't prove anything. A mathematical framework is just a model, and models are proven by testing. So the whole idea is you have to test it. You have to actually do the experiments and find out whether 4 pounds dropped 1 foot is the same energy as 1 pound dropped 4 feet. As an example of a scientist, you have failed the testing. Okay, clearly you have no respect for the scientific method and the foundational ethic of testing and retest. Test and retest. I claim it's an obvious fact that conventional physics makes proclamations regarding the truth that are way too under evidence to be asserted with any confidence. So it's all just hype and talk and very little demonstration with anything that actually happens in the physical universe. The kinetic energy theorem is plainly junk science, and you are a junk scientist to promote it as credible science. All right, quoting him, I won't take your bet because you won't accept any of my results. I don't accept any dogmatic religious theories, appropriately including yours. Unjustified faith is not a result of anything but ignorance. I guess you are free to decide that I'm just another part of the conspiracy hell-bent on describing mechanical systems using Newton's law. So again, he's claiming he's a Newtonian when clearly he's not. If Newton could be resurrected, he would despise you for your slander against his hard-earned insights. You're just stomping on the shoulders of giants. All right. Yeah, then he says it hardly raises to the level of a religion, but you do you. Okay. I'm the one demanding evidence. You're the one reading out of a book of delusions. Just a fact. Okay. It illustrates well how Steve applied the work. It illustrates well how Steve applied the work-energy theorem incorrectly. So again, he still hasn't. All right. So I said the fact is you still won't concede. The fact that you still won't concede this is a false accusation is just more proof of your belligerent ignorance and unrestrained arrogance, which it clearly is. I mean, he's just so arrogant, so thinking of himself as somehow infallible, that he can watch part of a video and he knows what the whole video is about. I mean, I just can't imagine somebody watching the video and then not watching the rest of the whole video. I mean, why did you bother starting the video if you're not going to watch the rest of the video? Just amazing. Or didn't pay attention to this. I don't know. It's doing something. It's distracted. I don't know what the excuse would be. But anyway, just funny. In a sad and tragic way that these people really do think, that they're on some sort of honorable ground, and all they are is despicable, lying cowards. Frankly, it's the only fair description. All right, so till the next whatever it'll be. I don't know what it'll be right now, so I will add something else. Who knows? Alright, so I guess I will deal with a comment. Rather than try to write a response, I might as well make a video response because it's an interesting enough subject. So if you put an anvil behind a rifle, suddenly it's not equal and opposite anymore. So I have tried to qualify my acceptance of the third law and just saying, okay, generally it looks like. But if you really think about it, okay, if I throw this away, it's like I lost this motion in that direction. And now I have less motion in the that direction. So my equilibrium is now unbalanced. I gave away this way, so now I have more this way left. And I sort of just analogized it to currency. That's what everything has as a currency, an amount of this motion stuff. And all you can do is exchange it. You can give it away. And so there's no opposite reaction that takes it away. Once you give it away, you've automatically given it away. You've lost it, so to speak. And something doesn't need to extract it from you because you already extracted it from yourself by giving it away. All right, and that the third law is basically just a nice statement regarding conservation. All right, so I attempted to explain it by saying this crap. Well, I certainly didn't indicate it was suddenly anything, and as I believe you can reflect 100% of something's momentum, that is, I can throw something, it can bounce back and hit me in the head. That something can reject the energy I've offered it. Okay. I have clearly qualified my use of the third law as just a statement about conservation. I repeatedly pointed out that energy momentum can be analogized to currency. If you have $10 and you give away $5, no opposite reaction makes you only have $5. You already gave it away, you don't have it, that's why you're poorer. Or in the case of motion, that's why you now have a bias in the opposite direction, is because you gave away what was balancing you, so to speak, relative balances. Again, this all has to be understood that we don't know for sure what's actually moving where in the universe, and that all you can do is make relative comparisons. The third law, it's an effort to summarize all interactions in too few words. So you could just say, yes, it's trying to say something really simple to explain a whole bunch of complex physics. And it might be a little bit of an understatement. Okay, obviously the mechanics of collisions aren't exactly the same as the mechanics of explosions. So obviously an explosion is you're sending stuff in both directions. So there's a balance. And in other cases, it's only motion in one direction that's involved in the system that you're monitoring. So in one system, you're monitoring the origin of motion. And in another system, you're just monitoring what happens when one element of the motion hits something. Beyond the common principle of conservation. Okay. And so he replies, you have stated that momentum is used to calculate thrust. Duh, yes. That's true, but now you are contradicting that. So I'm not contradicting in any way whatsoever. Your idea of reflection completely ruins the idea of thrust. No, it's actually part of why rocket engines are built the way they are. It's because they're relying on reflection. If there is a reflection, according to you, the exhaust and the rocket won't have an equal and opposite motions. Yeah, of course they will. And what would even determine the amount of reflection? Can NASA calculate it? Well, of course they can, and they test it to calculate it, frankly. Because it is very subtle, so you have to test rocket engines and see how much you get out of the rocket engine based on how you manipulate the flying particles. So you can manipulate them to your advantage. You can even direct them in different directions, which, as much as I hate SpaceX, I mean, they do have rocket engines now that can, be directional to some extent and be able to keep the aerodynamics of the rocket level and even. And so I'll draw some of that. Yeah, that's what I should do. I've done it before, and it is really interesting physics, but I'm just saying, so we could just take an isolated tank and we just pressurize it. So it has a bunch of elements of stuff in it, and they're going in all directions. So you can understand, I can take the energy out in any direction I choose. So the energy, each little unit of energy has a vector, and it's going to have a certain path, and it's going to do certain things, but inevitably all the energy hits surfaces, one surface. Any one surface in there, there's a probability over time it's going to hit that surface eventually, the piece of energy. And the idea is that I could make a hole anywhere in this vessel. I could even make a hose, okay? And I could just open the hose in any direction. And the truth is that any particle that escapes has to basically end up going in that direction. And so the vessel itself, the whole thing, as you would take it as a container, basically is saying that you just took a piece of energy that was going to hit the side here, and you've basically let it free. So now the balancing pressure, okay, the impact pressure, is now not going to be even, and now you're going to have more stuff hitting this side of the vessel than you have hitting that side of the vessel. And so you've essentially given away your balance. You have a balance, and you've just given away a piece of your balance. So the same thing's happening in a rocket. All you're doing is it's got a huge amount of creatable pressure. Some of the pressure is in the form of just pressurizing the hydrogen, but obviously the real pressure is in what's going to happen when you combine the hydrogen and the oxygen. So you're going to combine, okay, the hydrogen and the oxygen, and you're going to make big molecules. So you're making something that's expanding. So they're going to expand the space that would be occupied by the little molecules. You're going to expand the space they take up as objects. And so they're creating pressure in all directions. And so that's adding pressure to the pressure you created. That's the explosive pressure, is that the tiny things are now big things. And now the obligation is they're going to fly out this way, generally speaking, but they're going to fly out this way and that way when they're expanding in the nozzle. That's where they're expanding the most. And so what is the nozzle doing? Right, so I should probably draw that better for the purpose of explanation, is that it's going to absorb that energy, okay? And basically it's taking the stuff that's going to end up reflecting and is causing it to create a new direction. And so in doing that, it's putting pressure on the opposite direction. So there's an element. So it's going this way, but obviously this way has a vector this way. And so it's gaining extra energy that way because it's forcing things that are going in useless directions to go in useful directions. So by channeling the exhaust and forcing it to go in one direction, you're increasing the pressure you're placing on that direction because you gave away this way. So again, it's just the idea that it's giving away arrows in this direction, and it still has arrows going this way. And so obviously the balance, if it gives away these, then it doesn't have the same balance. And now it has more energy going one way than it has going the other way. And that's why it moves that way. It's because there's more energy going to hit that side. All right, now the only thing I would concede is that obviously this requires something to be capable of doing this elastic thing. So the whole idea of the rocket is to create surfaces that don't absorb the energy, okay, but they reflect it and they absorb it, and then there's a reflection in terms of that would be a more like an equal and opposite reaction in the sense that the energy has to come out of the rigidity of the material in the terms of the, so we could use this box example. I mean, so again, we're back to this argument that you put a unit of energy doesn't die. So if I throw something in this direction, and the box moves now in this direction, but it reflected this, okay? So it's doing two different things. It's moving this way, and it's reflecting the energy. So those are two different motions, but they're understandable as, two different motions. Now you could say that it hits the surface and stops, but we know that's not what things do on the elemental universe, is that they hit things and they either move the object, and eventually the object ends up hitting more energy, and then it's going to be an inevitable reflection because it's going to go into more energy than because of its motion, and that is going to mean that that's going to create the extra energy to say reflect. So it's complicated. You can't just say, oh, it happens in, there's one action, and the one action is all the action there is. But I would say for big objects, you're not going to see any of that. You're not going to see why the steel is elastic. Because we can't see what's happening inside the steel. We can't see that the electrons are moving, but they don't move far enough, and so their charge forces compel them to move back. And the only way the charge forces could do that is because first the electrons had to move into the rain, so to speak. They had to move into the force, encounter more force to be pushed back into the object again. So in that sense, it all does have this equal and opposite reaction, but I'm just saying visually you're not going to see any of that. And the real bottom line is what's going to decide which way a balloon travels? Well, it depends on which way, where the opening is. So I just change where the opening is, and I change which way it goes. And why does it go that way is because that's the direction I'm expelling the energy, and this direction, obviously the energy is still applying pressure to the other side. So, yeah, I think that's probably enough of an answer. And such. Oh. Yeah. Oh. There's another comment. It's a long comment. I don't know, do I want to read that now? I don't think it's going to be very useful. But I suppose we could go and see. Since I'm here, get rid of the image. Which, well, I should just really erase it, I guess. I should just pause. Alright, so it's, a big long pile of crap. So, let's see what it says. I have a suggestion. As many of the cases you describe at length ad nauseum. Yeah, well, fuck you. It would only be ad nauseum because there is no evidence, and nobody's advocating for the creation of evidence, and so people should say ad nauseum, show me. That's a reasonable thing to do, ad nauseum, in a scientific community. That should be perfectly reasonable. Are really not very complicated. Well, whatever. As U.S. gun owners should have a gun and a tachometer. So why would a gun owner have a tachometer? I mean, I'd say, 1 in 1,000 gun owners? To detect the velocity of the bullet can be weighed. Or in fact you can just detect it and get more velocity from changing the gun on the bench and holding it. Yeah, so all of this can be done. I didn't say this was a difficult experiment, did I? No. I'm just saying, how do you think a ballistics experiment should be done? With high technology, high speed cameras, all kinds of great stuff, or should it be done by some slob in his basement? I'm just saying, you think science should be done by slobs in basements. I don't think so. Especially in the atmosphere where they spend literally mega billions of dollars on obscure nonsense physics. You're saying you can't spend a few $1,000 to test this stuff? I mean, that's your physics. I mean, you're defending what I would argue is just ludicrous. You won't spend the $50 to do the Eddington experiment from space? I mean, it's nonsense. And again, what am I supposed to build satellites and send them up there to do it? Fuck you. Let's see. Your other idea could all be tested pretty easily by a competent person with a few tools. So again, that's why you want the science done. We've already seen all of these rigged little experiments and how many defects they have in them. So you think that's good physics. I think that's flat earth physics. Okay, that's what flat earthers want, is shitty experiments. Fuzzy images. That's what the Sasquatchian people want, okay? They want blurry images of people in gorilla suits. Springs can be compressed and then released, elastic bends used, etc. Bands. Yeah, again, there's a real physics to all this stuff, and we've learned a lot through doing some of these shitty, sloppy experiments. But the fact is they should be done well. And again, what is so complicated about that argument? Why don't you understand the argument? Instead of somebody doing it with a crappy camera with, whatever, 60 frames per second, don't you think it should be done with one of those 2,000 frame per second cameras? Wouldn't that be a hell of a lot better if we're going to count frames? I mean, you're just so full of shit. I'm sorry, you're an asshole. Defending crappy experiments is not a great thing to do, okay? It's just really pretty fucking stupid. All right. Would it not be a sensible idea on your channel to have a simple document describing the experimental setup? Yeah, well, I don't know. There's plenty of that, okay? I mean, I've done the 5-minute videos explaining experiments that should have been done, all right? Now, you want to explain exactly how you want to do an experiment to a physicist. I don't know. Maybe that's sort of insulting him, right? That he can't figure out how to do the experiment. The engineer can't figure out how to do it. It's not my job, frankly. For a few of these ideas and the results expected, question mark. So we did do this. We've been here and done that, right? So the physicist Michael guy was supposed to do the lever experiment. And what did he do? He said, well, I don't want to hurt my little cart, so I'm going to put clay on it. Yeah, I'm going to completely ruin the experiment by putting a deformable substance on the bumper of the car so the car can't transfer its energy. I mean, it was so ridiculously stupid that, yes, there was absolutely no point in doing the experiment. At the key moment, doing the key experiment, he decided to put a lump of clay on the cart. Ridiculous. Absolutely fucking ridiculous. Okay, rather than engaging in the drama and name calling and I don't know, hectoring, which I'm sure is the result of many years of like responses. Yeah, exactly. So it's completely appropriate to call shit when the shit exists. And the fact is, all these shitty physicists are cowards. They can't engage in the conversation, and what they can't do is they can't produce any evidence for their faith. And that's all it is. It's a religion. They can't defend it as logical or sensible because they can't produce any physical evidence of its reality. And we can go over and over all of the examples. I can show you a video where another physicist will tell you that car crashes are all about momentum, and that's all that you need to analyze. It's the momentum. Kinetic energy isn't involved at all. And then they'll say, well, if kinetic energy is involved, the only involvement is it creates heat. It creates some kind of useless effect, but it doesn't provide anything mechanical in the system. I mean, it's all over the place how this stupid theory fails dismally. Ballistic pendulums, crashing cars, hydraulics, it doesn't matter what you choose, levers, okay? So, and again, did they show you a lever experiment? No. Why do you believe in this crap? What have you seen that convinces you that you can destroy momentum with a lever? All right, in fact, the ideal would probably be an air gun of some description. Oh, okay, so now you're going to describe an experiment. Well, why don't you write a paper? Oh, as it is used, as it uses a compressed spring to create energy to propel a pellet. Well, again, you just said, I've already pointed out how, in the very video you're responding to, how springs can fail. So, I mean, what's the point? You don't get the argument that if a spring is pushing a light object, the spring can't get all of its energy into the light object because the spring, say if it's pushing something 30 miles an hour, well, when the thing leaves at 30 miles an hour, the spring is still going 29 miles an hour. So if it's pushing a big thing, then it's only going to be going 5 miles an hour. And so most of the energy will be in the object, and the spring will wobble very little. Pushing a light thing, the spring will wobble a whole bunch after the experiment because the spring didn't give away all its energy. I'm saying that's an absolute physical fact, okay, where you got to be careful using springs and assuming things about how much energy you're getting, because springs don't apportion energy the same to heavy, slow things as they apportion to light, fast things. Okay, use a pellet, blah, blah, blah. And then detect the velocity of the pellet. Well, I'm certainly not going to be able to do that, so thanks a lot, but no thanks. Look, we already had the ballistic pendulum experiments have been done hundreds of times with all kinds of different projectiles, and in every single case, nothing more than the momentum is ever collected by the pendulum. Nothing more, ever. So it doesn't matter how many millions of times more energy I put in, I won't get it. Okay, the speeding bullet with 1,000 times more energy will only give the ballistic pendulum the meager 2 joules of momentum. All right, setup 1. An untethered air gun on a surface pointing at a velocity detector is fired and allows the energy to go in both directions. Yeah, I've already explained this as a zip gun. You could take a zip gun, that gives you a perfect environment in the sense that, one end the energy just flies out and the other end a bullet flies out. And so test the zip gun and then clog the one end, okay, and then do it again and see if you get the same energy. And the argument I'll make is that when you've clogged the end, you might get some back pressure that will actually have time to get to the bullet. Because the bullet's not going to be moving the speed of light, and much of the explosive energy will be moving close to the speed of light. So there is a chance that it can reflect and create a higher pressure. It's not a complicated argument. It doesn't need all of this bullshit. Setup 2. A clamp in a bench vice air gun applies shooting through velocity detector. In this case, you expect to see an increase in velocity as more energy has been transmitted to the pellet. Yes, I'm just saying this doesn't have much to do with the subject. I'm just making the simple argument. Now, the more important subject is do you think a spring attached to a brick wall and I compress it, it's the same amount. So in 2 experiments, I'm going to compress it the same amount. In one case, it's attached to a brick wall, and then I have an object of the same size, and I release it. And then I just take the same size object, have the spring compress the same amount, and then another same size object, and then do the experiment. I mean, it seems kind of obvious to me, okay, that there's no doubt about the fact that you're going to get quite a bit more velocity into the object because the spring can't push any energy this way. It has to force all the energy the one direction. I mean, is that too hard a concept for you to say, yeah, that sounds pretty likely, let's do that experiment? Anyway, in fact, you could do this yourself, actually. I've done experiments myself, and they're not going to be good enough to be accepted by people, and so there's really no point. I mean, is there really a point in me doing crappy, 30 frame rate video of a shit experiment? Is there really a point? Okay, use a ballistic sled. So what is all this crap? We don't need any of this shit. Or even some clay stuck to a child's train track. So this is just too ridiculous. Then shoot the clay with the pellet. If the pellet has more velocity and therefore more momentum, it will move the car sled faster than the one with less velocity. So again, who cares? I don't have guns and I'm not going to do it. So fuck you. This is idiotic. It's not my job. You really don't get this, right? For 350 years, they claim a truth. 4 pounds dropped 1 foot is the same as 1 pound dropped 4 feet. And they've never tested it. It's my job? No, it's their job. Oh, I think you're just such an asshole. Anyway, I think you put up a document with some of these experiments which would need care, but are not beyond competent persons to care. Yes, and I've offered money for somebody to do the experiments well. So that's just a proven fact. I've offered, in some cases, thousands of dollars for somebody to do the experiment well to prove the point. So fuck you. I've done my job here. Given that the 1/2 mv squared is a formula and this differs so much in terms of multiples when tested, 4 to 1, 1 to 4, for instance, having the same KE. 4 to 1 and 1 to 4 having the same KE. The point is that they have the same momentum. They don't have the same KE. So you got it wrong again. 4 squared, that's 16. One has 16, one equals 4. 4 and 16 are not the same number. All right, just make sure you test using something which can actually sense the difference and show this. Well, that's the whole point. There's variables in these experiments. They have to be done carefully. So what's the fucking argument? The whole point is Steve Mould has proven over and over again that he's willing to do experiments in detail and carefully. But he won't do this experiment in detail and carefully. Okay, and it is large number should be golden, so whatever that means. Which wins? A 1-ton train going 5 miles an hour or a 5-ton train going 1 mile an hour? Well, if you don't already know the answer to this, I can't help you. All right. I mean, do you really think the one going 5 miles an hour has, that is a 5-ton. Yeah, he's got the two words smashed together. Do you think there's really any hope that the one has 25 times the energy? It's a ridiculous statement. Well, I get 12.5 versus 2.5. Well, then you did the math wrong, which means the faster train has significantly more energy, which means it doesn't have, but fine. 2.5 does not go into 12 25 times, so I just don't know how you got those numbers. 5 squared, 25, and times 1 ton, and then you have 1 times 5. Well, anyway, it's really my monkeys. It's really my monkeys would be on the 5-ton train, as I know, even though it's moving slowly, it has force. What it has is momentum. There's no hope with you people. Of course, they are really both the same. There you go. But my point with the simple example, we should be able to easily show the difference as it's a factor of 5 between them. Well, the point is yes, that I'll agree. It is a factor of 5. Sorry. But the real point is, all right, is that, again, this is another experiment where you have to say, okay, wait a minute. You have to calculate the angular motion in the wheels. So if you have a train, with wheels, then you have to understand that the one that's going 5 times as fast has 5 times the angular momentum stored in its wheels. So in a tug of war, that's going to be an advantage. So it'll have a slight advantage. It won't have a 5-time advantage, but it'll have a slight advantage because it's going to have a lot more energy stored in non-linear motion in the angular rotation of the wheels. All right, please take this as it's meant. Well, all I have to take is your first little stupid asshole remark ad nauseum. Yeah, fuck you. You think I want to do this ad nauseum? You think I want to spend 10 fucking years making this fucking argument, you fucking asshole? Of course I don't, but I can't get any physicist to respond. I can't get them to actually deal with this subject and prove their assertions against logic and reasoning. Okay, Steve Mould just made a video that got 1 million fucking views, and he basically said levers destroy momentum. And nobody's doing anything. Do you get it, fucker? All right. Please take this as it's meant. I think listing some sample experiments with given weights and so forth would be a super good future, as you can refer anyway to them and see if someone picks up and does a decent test. Yeah, we've already been here and done that. So every time I suggest an experiment, they fuck it up in some way. So it really doesn't work. And I'll go through all of these details after they've done the experiment and explain, well, what you should have done, right? I mean, Dispar just did a video where he put weights out here, and then he put weights in here, heavy weights. And he's arguing that somehow these lighter weights are harder to move. Now, all he had to do was slide them in a little bit, and we could just see when's the point where the two wheels would turn the same speed. Because that would just tell us, oh, maybe you just made a mistake and didn't get the distances quite right. Because it has to go all the way to 1.4 if their theory's right. And it's not going to go anywhere near that. And we know that's the truth. So, the fact is it's really easy for him to do the experiment where he actually tested the theory by, seeing where do the two wheels spin at the same speed. When does the mass on the outside have the same momentum as the mass on the inside? And I'll argue it's about 1 centimeter different than where he put the weights. Yeah, that's what I'll argue. All right. but they don't pay any attention. They don't give a shit about doing the experiments right. Anyway, I say blah 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 blah. Would be super good if someone picks up and does a decent test. If you yourself don't seem capable of getting some clay, so it's just too silly. And a kid's car or truck and an air gun. Yeah, well, I'm not going to do all of that. And I'm not even sure clay is the right substance. Because, again, what you're trying to do is capture all the energy of the motion, the linear motion. And clay does a lot of moving this way and that way. And it also, it's frictioned and sticky, so it creates heat. So maybe there's some better way to collect an object than clay, frankly. Some better system that collects it by it, going through a tube and rattling inside the tube. You might get a lot more of the forward motion that way. You might steal it through friction, using some other method, because clay just isn't that perfect. I mean, ballistic pendulums often use clay. They use gel now too. And they lose, there's a percentage of the momentum that they don't collect. And it's mostly because of the imperfect method of collecting the bullet's velocity. It's hard to catch things that have a high velocity. It's hard to apply friction to things with a high velocity. Friction that doesn't create deformation, that doesn't change the shape of things or cause heat. All right. So anyway, all right, well, at least we're done with the crappy comments. I think that's all there are. Leave us hope. Yeah. Okay, so maybe this will be enough of a video. Yeah, we'll see. See if I have anything to add before it is whatever you call it, upload time. All right, so just to throw a little bit added on. So their theory. So when you do a Newton's cradle and you have two equal masses, right, you can probably see that, and you let them do their thing, they just bounce off of each other. So whatever energy they take in, they end up just exchanging their momentum, okay, and there's no cancellation of anything. Nothing cancels. And so, you have whatever momentum, we could just say 100 in and 100 in, and you get 100 out and 100 out. So even though they're going to say later that, when you hit a 3 mass into a 1 mass, that somehow, this one has 50 and this one has 150, that somehow, okay, the 50s cancel, and all you end up with is 100 going this way still. So it doesn't make any sense. I mean, there's no consistency between these two actions, okay? All of the momentum being conserved, even though it's in opposite directions, it leaves with just as much momentum as went in. And in this case, you have 200 momentum come in, only 100 pops out. And so I was thinking, okay, so what's the catch? When's the magic moment? And you say, so I could add a little tiny bit of extra mass to one of these Newton's cradles, just a tiny bit. And you'd say, okay, so if I drop it from the same height, it's going to have a little tiny bit more momentum. And what's it going to do? It's just going to make this leave with, instead of, say, this was 101, and this was 100, well, this will leave with 101 momentum. And this will leave with 100. And they're just going to exchange their conditions. So it's not really possible to contrive some other. I mean, when does their bullshit start? Because if they go all the way from this 50-50 thing, how do they end up at some position where 100 goes in and 200 goes out in that direction and 100 goes back this way? I mean, it's, and just the very idea, I'm just saying, I mean, can't somebody say, well, yeah, it's impossible for me to send 200 this way and get all of my energy back and just do that over and over again? I mean, there shouldn't have to be an argument that doesn't work, that doesn't make sense, and somebody has to explain it. They can't just say, well, we have a formula. They have to explain how it's possible for me to get back all of my energy, every bit of it, and create motion in the universe. I can't make something move and not use any momentum to do it. I have to use momentum to do it. And right on that face, people should say, well, that's not conservative. That doesn't make any sense. You can't make something move in the universe unless you give it your energy, your force, your motion. You have to get the motion from something. You can't get motion from nowhere. Everything moving in the universe right now acquired its motion by interacting with something that was going the way it ended up going, and that's where it acquired the motion from. It can't acquire it from nowhere, and you can't make it disappear because two things hit each other, and all of a sudden that motion is gone from the universe. Not possible. All right. I mean, there should be a recognition that, okay, I get it. That doesn't seem right, and somebody's going to have to do some explaining. They can't just sit there and say F equals MA and walk away. It needs more than that. It needs a lot more than that. Anyway. All right. So, yeah, it's probably enough for that. I don't know if there's anything else I'll add to this video. We'll see. Oh, yeah, I didn't add anything. Just hit the wrong button. All right, so we got some more Paul Nord, which is funny. So, yes, might as well do it. So he says, thanks, Gary, which is nice and polite. It is certainly possible that Newton's laws have another derivation. So what's the point of, the law is so simple. Well, anyway, I'll read my responses. Technically, there are infinitely many mathematical formulations which might give the same answers. Yeah, but not into the same scope. I mean, what formula works all the time versus a formula that only works in specific cases. So that's the real test, is how durable is the formula. These theories have proven themselves to be useful. So again, you can keep saying things like that, but I'm going to make the counter argument over and over again. No, not when it really counts. When it really counts, NASA uses momentum, not kinetic energy. That's the argument, that we land on the moon with momentum, understanding thrust to be momentum, not understanding thrust to be any kind of kinetic energy. It doesn't obey Newton's third law. We build bridges, we make cars better, we fly planes. I point out that we also landed on the moon. Anyway, you're always welcome to find a theory or a case where calculating energy is not useful. Well, if I shouldn't be able to find those cases, that's the whole point. That really shouldn't be the case. If you have the right formula, there shouldn't be cases. Okay, but the proof is in the experiment, which is just so... I can't believe he says these words when that's what you're missing, is the experimental proof. Oh, brother. In the 300 years since Newton, no one has found a way to violate the laws of conservation of energy. Just amazing nonsense. I mean, obviously Newton, it was about conservation of momentum, okay? He didn't say anything about conserving energy. So it's just such bullshit. Good luck with that, he says. All right, so again, he thinks Newton believed in mv squared. When Newton said the exact, well, I've already quoted what Newton said, and it's not mv squared, that's for sure. So, hey, how come before it was showing my email address? Huh, weird. So it's not doing that now, so I guess I can let you read along. All right. All right, so it certainly is possible that Newton's laws have another derivation. When he stated under his second law that twice the force equals twice the velocity, 3 times the force is 3 times the velocity, I think he made it clear that force and momentum are interchangeable. So we don't need any complicated theories. mv has to equal mv. mv in, mv out. That's the law. All right. Theoretically, there are infinite number of mathematical formulations which might give the same answers. I said, theoretically, a mathematical formulation should describe actual root functions, not occasional indirect effects. So I would argue this is their MGH thing. MGH is only describing one silly circumstance where you drop something. You place something in gravity and drop it. It doesn't describe when something's already has a velocity. MGH will do you no good at all. The faster it goes in, the faster, if I shoot a bullet down into gravity, MGH won't tell me how much gravity, how much more velocity the bullet will acquire. It'll get the wrong answer. All right. These theories have proven themselves to be useful. So this useful word is just not useful. That's the part where I say, show me. So that's all this is about, is show me the evidence. Show me the usefulness of getting wrong answers. Because frankly, that's all you can do with kinetic energy theory, is get a wrong answer. Show me the kinetic energy theorem actually describing any circumstance where energy is transferred between objects of differing mass. Because it can't do it. It can't. Yeah, it doesn't. All right, so he says, we build bridges, we make cars better, we fly planes. Well, it's kind of not a great time to talk about planes flying. Yeah, we also crash them. So I state, we also landed on the moon, not using kinetic energy theorem. Okay. You're always welcome to find a theory or case where calculating energy is not useful. Again, the argument is, in any case where you move energy from two differing masses, your calculations will not be useful, unless you want the wrong answer. I didn't add that, but I probably could have or should have. But the proof is in the experiment. Here we go. You have no credible experimental evidence. You haven't linked to anything relevant. Show me a lever not conserving momentum. Show me it taking 25 times the energy to spin something 5 times as fast. All right, and he says, in 300 years since Newton, no one has found a way to violate the laws of conservation of energy. So again, Newton didn't have any notion of conservation of energy in any other form than conservation of momentum. Yeah, you are a perfect irony engine. Throughout this conversation, you are claiming levers, gears, pulleys don't conserve momentum. And then he says, good luck with that. And somehow it didn't accept the quotes. I don't know why. Very unusual. Gmail. Apparently I will, so he says, good luck. Apparently I will need some of that, as finding a physicist with any integrity appears to be needle in haystack difficult. So, they really are just such despicable, they're lousy thinkers, and they're just lousy human beings. I mean, what's the point? The argument is that you should have a ton of evidence. You should have so much evidence that you could inundate me with the evidence. You have so much evidence. And you have nothing. I mean, nothing you can show me that is in any way decisive, proving any of this nonsense. I mean, absolutely no go-to experimental evidence. Nothing. Oh, you're so obnoxiously arrogant. Oh, anyway. Amazing. Alright, so that's probably enough of a video. So I think I will say that's enough of a video for this video. And we'll see what tomorrow brings, and the next day, and the next day, and the next day, and the next day. And see if we can find some physicist who's got the integrity to defend Archimedes and the 2,000-year-old idea, okay, that levers conserve momentum, that levers create mechanical advantage by turning big V little m into big M little v. That's what they do. That's their function. Somebody else has got to understand that's how it actually works. Alright, so till the next time, and such and so forth and whatnot.